Let's have a look at this paper. Okay, so candidate name this February March 2020. Question number 1. Okay, so first of all, it says this is the question: sphere of radius this the force SI unit of K. So it is given FB is equal to K RB. What is R? R is the radius. Okay, and what is velocity? Sorry, V is the velocity, R is the radius, FE is the force. So they are asking SI unit base unit of this. So force is equal to, right, MA, that is equivalent to what? kg ms minus 2. This is equivalent to K, R is M, B, M, S minus 1. So this becomes what? M square S minus 1 is equal to into K is equal to kg ms minus 2. This being divided by that, so K is equivalent to kg ms minus 2 upon m square s minus 1. So this minus 1 over here, it will become plus 1. This minus 2, so m plus 1 minus 2. So it would be 1 minus 2. So base unit is coming kg kg m minus 1, 1 minus 2 over here, and this is minus 2, so s minus 2. Okay, now coming to part B. Use the value of the upthrust acting on the sphere to calculate the density of the liquid. Formula F is equal to, okay, so we have to find density. How we would be finding the volume? 4 upon 3 pi r cube, right? Pi r cube. So it says what's the radius? 2.1 millimeter. So please keep this in mind. This calculation would be tough. So you would be getting a value 3.88 into 10 to the power minus 8. So putting it in the equation, this is equivalent to 4.8 into 10 to the power, force is given, right? Minus 4 upon this 3.88 into 10 to the power minus 8 into G 9.81. So we are getting a density of 1300 kg meter. Okay, part C. On the sphere, draw 3 arrows to show the directions of the weight W, U, and the viscous force F. This is the arrow, right? We have to draw 3 forces. Weight, start with the easiest, always downwards. Okay, upthrust, right? 2 forces upwards, one would be FV, and one would be U. Okay. Determine the magnitude of the terminal velocity of the sphere. Okay, so for the terminal velocity of the sphere, first of all, we have to look the weight of the sphere is this, and the upthrust is this. Okay, so we have to find a terminal velocity. For that, we have to find FV. FV is equal to minus 4 minus 2.8 into 10 to the power minus 4. Since the downward force is equivalent to the upward forces. So to find this, we are able to calculate it. It's coming 2.4 into 10 to the power minus 4n. Okay, so velocity is equals to 2.4 into 10 to the power minus 4 divided by so this would be divided by terminal velocity of the sphere. So 17 into 2.1 into 10 to the power minus 2. R is a radius. So divide by KR using the first formula. Okay. So using this formula, we would be able to find out this. So our final answer is 6.7 into 10 to the power minus 3. I hope that students don't err on this, right? Why we did this terminal velocity? Because we have to find first of all FB, viscous force, and then we have to do this, right? So the error appears over there. Most of the students don't do this. Question number 2. Okay. We all know how to attempt this. Okay, whatever the horizontal distance is given, air distance is negligible, non-interacting, is droplet. Briefly with the horizontal, why the horizontal component of the velocity of droplet remains constant as it moves from P to Q. So as we all are aware that force in horizontal direction on the droplet is 0. Okay. Next part. Show that the time taken for the droplet to move from P to Q is 0.53. Let's have a look at the values. Yes, distance is this. 3.5 speed is this. So that's a 1 mark question. So look at the marks as well. 2.5 divided by 6.6. So it's coming 0.53 seconds. Next, calculate height h. Now, since it is of 2 marks, so it means that more working is required. So we can use this formula ut plus half at square or gt square. This initial is 0, so s is equal to half into 9.81 into 0.53 square, and we are getting a height of 1.4 meters. Then it says part C. For the movement of the droplet of water from P to Q state, explain whether the displacement of the droplet is important less than or more than or the same. So basically what displacement over here is the straight line distance, right? Or it is the minimum distance. So basically, so less than distance along the path. Calculate the magnitude and displacement of a droplet of water that moves from P to Q. Okay. From P to Q. This is P to Q. A distance of a droplet of water. Okay. So since it's a straight line, we know this, right? So magnitude of displacement that moves from P to Q. So this is it. We have to find this. We have found this 1.4. I think so. This is 3.5. So 3.5 square plus 1.4 square root, and we would be finding the displacement 3.8. Okay. Now the first question asking, it looks like a very difficult type of question. That water, right angles, this is this. The diagram is very complex. Okay, water hits the vertical wall with the velocity of this in the horizontal direction. The jet is this, that is water. So that over time the mass of water hitting the wall is 1 point. So m is equal to this. This is equivalent to 1.0. This one horizontal into 10 to the power 3 into 0.5 into 10 to the power minus 4 into 5 into 1.6. So final answer is coming 1.2. Next thing, horizontal mass due to hitting the wall, decrease in horizontal momentum. So decrease, it means like here we have to find change in momentum. Okay, due to, and they are talking about the horizontal part. Okay, so when we are talking about the horizontal part, so we would be taking, okay, m into v. M is 1.2, velocity is 5, m v, so 1.2 5. That's a 1 mark question. Magnitude of the horizontal force exerted on the water, right? Combination of momentum, three point eight. State and explain the magnitude of the horizontal force exerted on the wall by the water. If you recall Newton's third law, which states what? Has the same and opposite reaction, so 3.8. Calculate the pressure exerted by the wall on the water, right? So pressure formula F upon area, 3.8 divided by 1.5 into 10 to the power. Yes, minus 4. So the pressure is coming 2.5 into 10 to the power. Now, I just want you guys to have a look at question number 7. The last question was, it's like really difficult, right? Often the atomic physics in AS Maths, AS Physics is very like easier part, but like this one is a bit difficult, and I want you guys to pay attention to this because this is the part which has been like recently being part of. A nucleus of sodium 2211 decays by emitting this. A different nucleus is formed by it. State the name of another lepton that is produced by the decay. So if you recall, this reaction, you would come to know that the another one is U prime. So this is like often the students don't pay that much attention to atomic physics and then they falter at exams. Okay, nucleon number and the proton number of the nucleus that is formed by this. So nucleon number, of course, 22, but the proton is decreased by 1, so 10. Okay. The quark composition in this is changed during the decay. Describe the change of the quark composition of the nucleus. Again, thing to note. Right? Quark. So basically, if you look at it, protons and neutrons are composed of two types, basically, up quark and down quarks. And then each quark has a charge, right? A charge of plus 2.3 and a down charge, up charge this, and a down charge of minus 1/3. And the sum makes up a nuclear particle. Okay. So again, quarks have 6 types of flavors, right? Up, charm, down, bottom, down, and up. Okay. Then they are asking, they're saying, okay, a baryon consists of quarks that have the same flavor type. So as I have mentioned, the flavors up, charm, down, bottom, top, and strange. But we would be looking at mostly few of them. So baryon is basically any member of one of two classes of hadrons. Okay, and it is made up of 3 quarks. Okay, and the other type. Okay, so the other type of quark other than baryon is an antiquark or a meson, we call it. Meson or an antiquark. Okay, let's have a look at now the question. So describe the changes to the composition, quark composition of the nucleon. So we would, it just up changes to down. A baryon consists of quarks that have same flavor. The type of the baryon is -2e. For the negative one, it is -1/3. So calculate in terms of the charge of each quark, it becomes -2 multiplied by 1/3. So -2/3. Simply it's -2/3. Okay, state a possible flavor or type of the quark. So it would be anti. Or we could have said up anti. So this is like really important, this question for this year's paper as well, right? For May, June as well. So pay attention to this. Often we used to see that in the earlier parts in the electricity and other parts it used to have a difficult question, but now they have given a question difficult even in the atomic part as well. End of session.